Hello everyone. Hello. Hello everyone.
Hello everyone.
This is Dev Gupta here. Today we are going to be learning about machine learning algorithms. So today we are going to be starting with the linear regression. This is some of the most simple models that we are going to be using in machine learning. So linear regression is a linear model. In As we can say, there are linear model in which there is a linear relation between the input variables and the single output variables, that is the y, and the input variables that is known as the x. As you can already see here, I have a equation of a line. As you all know, an equation of a line is a linear model. Here y is equals to ax plus b, where a is the coefficient of x and b is the constant of the straight line. Here a is also known as the slope and b is also known as the intercept of the line. And first of all, we are going to be seeing the simple linear regression. A simple linear regression in which there is only a single input variable and we are going to be getting a single output y. So why exactly we use linear regression? For example, if we have given a data, that is the value of x, and we know the output y. This is some given data that has been collected using some research or some survey, and we implemented a website using this data. Now we expect the users who are visiting this to get a similar output from their given input. So for example, uh, there are various factors while considering the price of a house, like what is the location, how much is the area, and various other factors. So considering these factors, these affect the prices of the house. So if we put a coefficient for each of the variables input and a constant value, for example, then these all will give a output price for the house. Now we define, for example, we define an equation for this, and we input the area or the area of the land, and accordingly, and we get the price of the house. So this simple linear regression helps us finding this relation for the given input, and we already know the output, but we want to know the coefficients for those inputs, and for if there is a constant present, then we want that too. So for example, here we can see we are importing, first of all we are importing these libraries, the matplotlib, that is used for plotting the values, the input and the output. We are going to be using matplotlib. Seaborn is not used much here. We are importing the NumPy library and the pandas for the dataset we are going to be using. So we run this. It is allocating and connecting. And the libraries are imported. Now let's see an example. We are taking some random input for x, and this rand, that is the random library in the Python, we are going to be using in the NumPy. We are using the random library of NumPy, and we are producing 50 values between 0 and 1, and we are multiplying it with 10 so that we have a range of inputs from 0 to 10 in the floating values. and we are using the value 2x minus 5. That is, we have taking a line of slope 2 and having an intercept of minus 5, and we are adding some 0 to values between 0 and 1, so that we have some data noise in the data. So we created two sets of values, x and y, and using this x we produce 2x minus y values. And as you can see, I will print this x and y and plotting this value. So you can see it is a straight line having a slope of 2 and having an intercept of minus 5, and these 50 points are plotted on this graph, and these are the values. For example, as you can see, this is 4.17, around 7.2, and we have very small values as well, 0.014, like this. And for that corresponding x value, we are having a value of y we have produced, and we have plotted the graph for this. Now you can implement a linear regression model from the scratch. There are a lot of tutorials available for that too, but here we are using skitlearn library that contains a lot of ML models, for example linear regression and multiple regression, for random forest, and much more. So to import the library linear regression, we use from sklearn.linear model import linear regression. This is the statement you use to get the linear regression model, and we define a variable to define this linear regression model, that is model is equals to linear regression fit intercept equal to true. We are just it is one of the parameters. We are defining that we want the intercept, and we are here this fit is as you can see here also fit linear model. We are training this model with the given data here, x and y. We are training this model against this. We are passing the values of x. Here you can see you wanted to know why this we are passing this value as x square brackets colon and np new axis. That is, we are changing the axis of the data. That is, we are converting the row values into a column vector to be passed into this. We call the skitlearn once a 2D vector we passed for the data, and I will print this so that you can know how the data is being passed in this model. And when I run this, this will be passed into this model, and the model will be trained against this x value and the y value, and it will generate the two things that we need, that is the slope and the intercept, or also known as the coefficient of x and the constant of that line. As you can see the above data, this is the x value. It is now converted into a column vector, and as I told you that the model.fit needs x value should be passed as a 2D vector, so we have to convert it like this into a column row vector into a column vector. And then we passed a training or a test model to check whether we are getting the right input or not. That is, we are predicting whether the model is giving the right output or not. So we created a data here xfit, that is, we are creating 0 to values between 0 and 10, and I'm producing 1000 samples around, and I'm passing it into this to get y values from this model. That is, the model has already predicted the slope and the constants now, and now I'm passing the x values to know whether the output I'm getting, that is y, it is according to the equation of the line, that is 2x minus 5. So I plotted the x and y in the scattering, that is the training model, and I'm plotting x and y, that is in the form of a line. and as you can see, this line denotes the test data, and it is very perfectly fitting with the training data. That is, there will be a very less error we will be getting. And as you can see, this line has a slope of 5 of 2 around 2, not perfectly 2, and an intercept or the constant of -5. And you can also know what coefficient and the intercept the model found using the model dot coefficient, and coefficient can be many. So right now it is a linear model, simple linear model, that is there will be going to be only one coefficient. So I'm finding out only 0, that is the first value, and model dot intercept as constant will be only 1. So when I run it, and you can see the model dot slope, that is, as it is very with a proper precision of 2.02 and an intercept of -4.99. There is an error of only 0.01, and we can see the results are very close to the inputs. And as you can see, this was only for one value of x. Now in the real world, you can always know that there will not only be one value that is affecting the output. There will be multiple values. So we move on to the multiple linear regression, where we have values of x more than 1. So linear regression is more capable. So now as you can see here, when the value was only 1, we have only one x and we were getting only one value y. So the line was in a 2D graph. But as you can see, if we increase the value of x, that is, we are increasing the number of planes in which the line will be projected. So we are moving towards plane or hyperplane as we increase the x variables. So now the multi-dimensional linear model will be of the form y equal to a0, that is the constant or the intercept, and a1 dot x1, that is the first coefficient of the first value, then the coefficient of the second variable similarly. So as you can see, where we have multiple x values, and so this now geometrically it will be now from 2D graph to a plane in the 3 dimension or hyperplane as we increase the number of x values. It is very difficult to visualize how this will be, but we can train the model and know. So here also I'm producing some random data, but now I have added another value here, 3. As you can see here, I didn't put any value, the second value, because it was default set to 1. That is, I only want value only in one dimension. But now I am increasing the dimension of x, that is, I have now 3 values. I am producing a vector of 3 values for x, and it will be multiplied by 10. So let's remove this commenting and see what type of input we are passing. So as you can see, we have a vector here. It has 3 values for x, x1, x2 and x3, all between 0 and 10. And now I am taking the equation 1.5 x1 minus 2 x2 and 1 x3 plus 0.5. Here I am not producing any noise right now, noise in the data. I am taking a simple example and I am dot producting it, that is, as you can already know, 1.5 x1 and minus 2 x2 and 1 x3 plus 0.5, that is the equation now. And I have the value of x and y, and I have taken the model, previous model only. There is no need to change anything in this linear model. It is already efficient for multiple regression also. So I'm now training the model for new values of x and y, and I'm printing the intercept. Now I didn't take any indexing for this intercept because I want all the three intercepts now. So when I print the intercepts, I think we should remove this commenting as we have already removed the x and y. And as you can see, the intercept is very much efficient, that is 0.5 what we have taken here. And as you can see, the coefficients are very efficient, 1.5, -2 and 1. It was able to produce the exact same input we have given to it by the model. That is, the model is working very efficiently. Here y is constructed from 3 random values of x, and the linear regression recovers the coefficient that was used to construct the data. In this way, we can use the linear regression to fit lines, planes or hyperplanes to our data. And there are much more regressions to be covered. If you know, there are multiple or more categories, robust regression and much more. So you can either we will be covering this in the other sessions, or you can study it from the internet as well. Here we are taking an example. You can find this challenge housing price prediction on Kaggle as well. Let me see, kaggle.com. Complete housing price prediction. Here you can take part in this challenge and use the linear regression model and slowly take more efficient models. So I've already uploaded the US pricing data set into my drive. I'm mounting the drive to this. The drive is already mounted, and I will be, let's remove this all. I tested this once to know that there are no errors. So let's import the data. So we use pandas here, and we are reading the CSV file that is been uploaded already into the drive. It is in my drive in data USA housing .csv, and to bring the CSV into your notebook, you can use pd.read CSV, and the link or the path where the data has been stored, and I'm storing this in data frame df variable, and using with the variable name .head, you can output some of the values, that is starting 5 values or 4 values of the data frame into your notebook. So when I run this, I am having this, that is, this data set contains average area income, that is how much values is the land, what is the age of the house, how many rooms does it have, how many bedrooms does it have, what is the area population, the price, that is what we want to predict, and the address. So according to the data set constructor who has constructed this data, according to him, these are some of the values that affect the pricing of the house. These values: area, average area income, the house, age of the house, how many rooms does it have, how many bedrooms does it have, what is the area population. All this affects the price of the house in US. And these are the addresses that were used in the survey, and we have those addresses. And dataframe.info, this will tell whether we have sometimes in the data set there might be some null values. Sometimes you cannot find some data. For if the sub person dies, he doesn't know what was the age of the house, we cannot predict sometimes, so they leave the data as null. Or they don't know the address, so they leave the address as null. They don't know the average area income, so there might be some null value for that. So df.info, it helps us tell whether there is any null value in this. How many values are there? That means, as you can see, there are 5000 entries here from 0 to 499, as the numbering is from 0 here. And in there are total 7 columns, and the first is average area income. There are 5000 entries. There is no null value here. That is very helpful for us. That means we don't have to clean the data here. I have taken a data set that does not have any, we don't have to clean the data. But usually if you start with ML, there might be some data set you will receive that might have some null values. So there are different cleaning techniques that you use. That is, either you remove the entire data, or you put some mean value there or median value there to replace that null value. So a lot of cleaning techniques are taken into consideration while you receive a data set and you apply some model before that. So here it is very good for us that we don't have to do any cleaning right now. That is, all the values are non-null, there is no null value. And this defines the data type for each of the data. That is, we have average area income, that is in float. Everything is in float here except the address, that is an object, because it has multiple values, that is string, and this it is not giving properly what is string or this. There is, and this is defining that there are 6 floating values and 1 object only. You should always do some of these steps before constructing a model or something, because it is necessary to know how many entries are there and what is there are their null values. Sometimes people apply they are trying to apply some addition or subtraction, and they don't know that they are applying to an object or a floating value. So these data types are very useful to be known. What type of data are you working with? Now df.describe. df.describe, it is also important. It is giving how many, what is the count, as usual, as we have already know 5000 entries are there. And for the floating values only, as you can see, we don't have anything for the address because it is an object. There is nothing much to do. That is, there nothing to find mean or standard mean or min value for that. So it takes only consideration of the floating values only. So we have a mean value, that is, what describe did was it added all the values and divided by 5000 to find the mean value for average area income. And as you can see here, it means that of all the houses given here, age of the house, average age of the house is 5.9, that is around 6 years. What are the average number of rooms? 7 rooms around, and there are average 4 bedrooms. And what is the average area population, and what is the average price given in the data set. Now STD, that is the standard mean, these values are found. Later, the minimum value in the given column of average area income, minimum value is 17,796. What is the minimum age of the house? That is 2.6, that is 2 years and 6 months around. Minimum number of rooms 3.2, minimum of bedrooms 2, average that is the minimum area population. And what is the minimum price here? 25% like mean is the least, then 25% value, 50% value, 75% value, and the maximum value here. As you can see, the maximum area income is around 1,07,701. So basically here what we need to know that these are the values that is affecting the price here, and this is the why, that is we want to find the price given these parameters or given these variables. We are trying to find a relation between these values, and this value, that is the price. df.columns, it gives the number of columns, the name of the column that we need. But as I told you that we need only the x values, that is these values, the average area income, the average area house age, the rooms, the bedrooms, and the area population only. And what we need as a y, that is what we want to find, is the price. Now let's run this as well. Now what we are going to be doing here is we are going to be dividing this data set into two. That is, one will be a training data and one will be a testing data. Why do we do this? Because the model is going to be training on one particular data set, and now we want to give the model some unknown data that is not, it has already been trained for. Like in paper, you study the study material, and there now the teacher tests you with some given test to know whether you are giving the same output, that is what you have learned, against some unknown questions that you don't know. That is why you give the test in the colleges or the schools, to know whether you have what you have been trained for, that is the data or the resources that you have learned, whether you know it properly or you are lacking in some area, to test your accuracy. How much accurate are you applying those things against some unknown data or against some unknown questions. So here sklearn the model selection, that is I'm selecting a model and I'm importing this library, and I'm using train test split, that I want to split the data into test and train. Here I've defined when I use this library, it usually gives 4 outputs, that is it gives x train, that is the training x value, test x value, y train, and y test. And I'm splitting it in the form for, that is 0.6, that is 60% test training data and 40% test data, and random state, that is I want it to be completely random, that is there should not sometimes you divided it in like I would say randomness helps in helping the model train more perfectly, I would say like this. So let's divide the data. These are some of the functions that have been defined. We also want to know whether how much efficient is our model. Sometimes we are testing the data, we are getting some values, but some of these values, that is these values are known as like mean absolute error, mean square error, root mean square error. These help us to know whether how much efficient is our model. These are the loss functions that we use against our model. So I've defined some of these. These are already present in the library. sklearn matrices, matrix.mean absolute error, mean square error, and it is basically square root of the mean square error. Now As you know, we have taken from sklearn linear model, import linear regression again. Not run this. Let's run this too. Now I'm importing this, and I'm now training it against the X train, that is the training X dataset against the Y training, and I want to find the coefficients for each of these values against these X values, that is average area income. Against for each of these values I want a coefficient and a constant if there is. It is using this X train and the Y train to find a relation between this data. It takes a lot of complications to find, and linear.fit model helps us finding this. And it has been already been trained. And here we are going to be printing the intercept. Let's print the intercept. It is around minus 2640159.79. Okay, and this is the coefficients against each of the columns. That is, for the average area income I have a coefficient of 21.52, and likewise for the house, say this is the coefficient. For the rooms, this is the coefficient. These coefficients are found, and you can see the linear dot coefficient. I used the X column. Data frame provides. I'm converting it. This was converted into a data frame for better printing, and now I'm printing it using this. I'm using some predictions. As you can see, this is a linear model. I found a linear relation. This hyperplane was trying to be converted into a 2D graph here. This is a plot for Y test and the predictions. These are the predictions against the X test and the Y test that we already had. It is against the plot is against this. And as you can see, these are the regressions. That is the matrix I told you already. That is the mean absolute error. And if you want to know the formula for these, here are the formula. The mean square error. This is the value that we already had, and this is the predicted value. So here we have the predictions. We pass the testing data into the model to predict the value of Y, and we already knew what should be the value in the Y test for the X test data. And here are the predictions. So as you can see, the data is very close. It has been scattered, but it is almost linear, as you can see. These are the formulas. This is the mean absolute error. This is the mean square error, that is Y prediction minus the Y reference. Y reference is the Y test or the Y value that we already know, and Y prediction is the predicted value from the model. And their difference will tell us how close are the values. That means if the value is around, if the difference is 0.001, that means it is a good that we have predicted very closely. So this we are using these matrices to find how close are these values. So from the mathematical point of view, we need all of these values to be reduced as much as possible. That means I want to get these values, the values for these loss functions, to be as minimum as possible. As you know that the difference should be very less if the values are very close. The predicted value and the test value we already know, Y value we already know, the predicted value should be very close. So all of these loss functions, we need to minimize them. So let's see. These are the values, the predicted values, the difference. This is seen to be very high values, but according to the data, it is very quite minimum. And here is a value, that is cross validation. That is how much percentage is that, how accurate were our predictions, that is around 91%. Around 91% we perfectly predicted the values. The accuracy of our predictions was 91%. So I think here we come to an end here. You can participate in this house pricing prediction competition on Kaggle too, using this tutorial we had just had here. If you have any questions, you can comment them. And we'll be providing this notebook into the WhatsApp groups you have been added to. Thank you very much.